Okay guys, welcome to the drawing board. In this section of the drawing board, we're going to talk just a little bit about the flow of our surfaces. How when we move one point, it affects the others and the polygons or the primitives around it. Okay, to have a polygon, you have 4 points: 0, 1, 2, and 3. Okay, these points, when they are joined together, gives you a polygon. And a polygon have 4 edges. Okay, 2, 3, and 4 edges. See, when we move one edge, it affects all the edges around it. So we're going to experiment something small to see what happens when we move stuff around. And you have to also know that to create something in 3D is the movement of the point that gives whatever you have a new shape. So right now, if I move point number 3 up, we see that it's also affecting the surface of the geometry, and it's moving this edge and this edge. Okay, so let's try it again. We move it up, we see the surface, the light reflection. This is not a movement of the light. The lights are all stationary. They are on the same spot, just like right now that we are not doing nothing. They are not moving. Only the mouse are moving. But we see that the surface are still, there's nothing moving. As soon as I move this point to another position in 3D space, we are in the 3D space, all right? If we tumble around, we see that we don't have no more plain surface. We have a crooked surface. We have a surface that is bent. Point 3 have moved from its original position, and now we have what? We have an angle right here. So we don't have no more perfect surface like we had before. Okay, we don't have this no more, you know. So a movement of a point or an edge affects everything around it. So let's say if we divide this geometry into 2 polygons, okay, we have 1 and 2. See, we have 1 and 2. Okay, so now if I move this point, what happened? If I move this point, we see that it's still affecting the surface on the neighbor polygon. This area is affecting this area. Okay, it's not only affecting here, so you will assume probably that, okay, because this point belongs to this polygons, its surface movement will only affect here. But now we could tell that it's affecting this side. Let's try it again. We move it here and we move it down. We see that the effect is kind of like affecting every part around here. Okay, so what's going on? Let's try more division and see. Maybe it's because it's 2 polygons. That's why it's able to affect the neighbor. So let's try and increase what we have. Okay, now we have a few more polygons. So let's try and start to move a few points. But let's try with 1 point right now and see what's going on. We see that as we move 1 point, it's affecting all the geometries that are around it. Okay, it's 4 polygons that are around this point that are moving. 1, 2, 3, 4. And the movement does not only even affect these 4 polygons, it also affects some stuff here and all around. Let's see what happens. You see, it's affecting stuff around it. So let's try to move more points. See what happened. See, the effect is getting stronger because more polygons are moving, and we see the lights are moving, and it's not the light in the scene that is moving. It's because these points are moving. And that's how when you move points in 3D space, it affects the shading of your geometry, you know. So how do you fix stuff like this? If you don't want none of the surface around here to be touched or no movements around here, how do you solve something like this? This is when you divide this area. You support the area you don't want no movement to go. You have to block that movement. But to block it, you have to get one extra line around here. That is what we call edge loop. Try that, maybe it will be clear for you to see. So we're going to add an extra line for support. So we'll try that right now. Okay, so now let's add an extra support line or edge loop around this area. Okay, select these points. Okay, and we move it. What's happening? We see clearly that there is no effects going on around here. See, so pay attention around this side. You see, there is no light or any shade reflection going on past this line. What this is teaching us is that in order to block the flow of lines and the effects going past where you want, you have to add an extra loop or block it with an extra line. Okay, so that is very, very important. So what is the use of this? Okay, this is very useful because when you are modeling, in most cases, this is what you are dealing with. You are blocking stuff and you don't want stuff to happen into places and stuff. Divide this stuff. The subdivision is going to bend this stuff, and it's bending stuff where there is no points or edges over there. Like in middle here, there is nothing here. So let me show you real quick. Let me show you, because I think it will be much better to show you. So if I select these points, okay, if I select these points and I move it, what's happening? We see that the bending is not happening in the middle here. The bending happens right here at these points. Okay? The bending is happening right here, the same as over here. So let's get a little deeper. See, the middle here, there is no bending. There's no bending middle here. You know, so if I want my bending to happen here, I have to bring a line there. So let's try that. So if I bring a line here, boom, maybe one here because we want the bend happen in the middle here. And now we go back to our movements and we move. What's happening? The bending happens in the middle. It's no more happening over here and it's no more happening over here. So let's try to block the flow and get it very close to the points we are moving. Okay, so if we move the points, you see, now it's happening right here. And we can see that we still have some light coming around here. If we don't want that, if we don't want the shade, we don't want none of our polygons around here, the face to create, you can see here, it's bent. It looks like it's bent. The reflections is here. We see all that, you know. So how do we stop these effects? So let's try more edge loops and see what happens. So we will get another line closer. Boom. Another line closer on the other side. Boom. Let me try it again. Another line. Boom. Okay. So now let's go back to the movement. See? The movement of the reflection of the light is what? It's only happening within here. It's no more going back and forth over here. You know? So we are able to move our stuff and then prevent all the movements around here. That's how you are able to get sharp edges even though you bend your geometry and then the rest, everything is moving, but what you are trying to protect stay the same. So the movement are happening just right here. So if we want to make it very tight, we will get the edge loops very close. So basically, this theory, when we get to modeling, you will see that it's happening everywhere. And we will be using that to protect the edges where we want to keep them to be very sharp. And then edges where we don't want them to be very sharp, we will leave it and they can bend. You know, you can see some bending going on around the edges that have no closed edge loops. All right. So this is very important, and when you understand it on the drawing board like this and you see the reflections of the light, it will make it stay in your head. That way, when your geometries are being deformed and you don't know what is going on, then you know that the flow of the deformation is affecting the rest of the geometry, you know. So we will end this section of the drawing board and I'll see you guys in the modeling. All right.